Hello, this video will be a brief introduction to using R, the R programming language that we're going to use for various business analytics or data analytics in class. And if you go to the R page, there is intro_r.r. This is a file you can download, and you can either use the installed version of R in RStudio. There are some instructions in the course about how to install those and a link for you, or it's much easier to use Posit Cloud. So I'm in Posit Cloud, that's where I am, and I have the file open here. Really quick, I'm going to delete this CSV because we're going to create it later. But just first, this is how it looks inside RStudio, and you can see that we have 4 different areas. We have this area is where our code is, our console down below. We have an area over here on the bottom right where right here we're viewing our files, but we also can view plots and help and other things in here, which we'll see in just a little while. Up top we have our environment, and also all of these windows can be resized, so that way you can move them around based on what you need to view. Okay, so here is the R script over here, and this walkthrough assumes that you have some familiarity with using a Jupyter Notebook and using Python, since that's what we did before in the previous class. So there are some things that are different. We don't have markdown cells. In fact, we don't use cells at all in this type of IDE. So instead we can run blocks of code in chunks, or we can run them line by line, and you see these 4 panes instead of that long linear structure of the notebook. When we do some work, we'll see things pop up in the environment. So first we'll take a look at a print. One thing in the Jupyter Notebook, if we can use print in the same manner, and it would print things down below. But for calling a variable in a Jupyter Notebook, you can actually just use the variable and you don't need the print. Well, it's a little different in this style of IDE because you do always need to use that print or display and so on. So here I have 4 different types of variables here: a numeric variable, a character variable, a boolean, and a vector. So I will just run this first one here. I can highlight it, or I can just be on the line and I can use the run, and then I'll see a value has popped up in my environment over here. It's called my number, and it evaluates to the number 42. If I go to the second one, this time I'm going to use Control Enter, and that way it lets me do the same thing. It runs the code of the line that I'm on, and now I see that this string has popped up. The variable name is my string, and this is what it evaluates to. It says, "Hello, RStudio," with a friendly exclamation point. Next we have a boolean, so I will go ahead and run that with a Control Enter command. And again, we see that we have our boolean up here in the environment. We get a little preview once again of its value. And finally, let's do a vector, which is like a list. And so when I put the vector in there, I also get the preview of the value up in the environment. All right, next I will show you a little bit about this cat function, which would be for concatenate. Most programming languages have a similar function. So when I run this, we're going to get the string number with a colon, and then we're going to get my number because it's comma separated, so it should evaluate to 42 because my number is 42. And then this here, this with the quotes, the /n is for a new line. So I'm going to run this and show you what I mean by that. Down here in the console, we can see that we have printed the string number right here, and comma separated we printed the actual variable, which it's displaying its value, which is 42. And then a new line, you can see that we are on a new line since it's indicated just here. So let's do these two as well. This time I'm going to run a block of code. So I have both highlighted for a block, and I will run, and we get the same thing down here. We get our string, and then we get our Boolean, each time dropping us to a new line. So in this next one, I'm going to show you what it looks like when we don't add this new line. So I'll run this block of code, and you can see the result here. Instead of having my vector and the vector on the same line, we have different, well, let's see, I can't see this because it's behind a thing for the recording. All right, let's move on. So ways to run code, like I just mentioned, Control and Enter, but if you're on a Mac, that's Command Enter, and it will run just the current line that you're on or the selection if you're running a block of code. If you need to run the entire script, then you can do Control Shift Enter. There's also the Run button on the toolbar, and you're able to copy and paste into the console. You can actually run code down in the console as well. The console is a handy little way to look at what has been run so far, but of course you could clear the console by using this broom, and then there wouldn't be anything there. But you can write code and run code in the console. We'll see an example of that in just a bit. Okay, so next we're going to show you how you would make a function. So we're going to make a function here using the function button, and we are going to call it calculate area. I'm going to run this entire block of code here. So we're just going to run this. So now we have a function up here, and it's displaying in our environment. We can see we have the following values active for us to use, and we have a function. We can test the function. So we're going to calculate the area of a circle that has a radius of 5. And we get circle area up here with its value. We can see that we have a float up there. Next, we will show you how you would create a simple data set. This is a data set from scratch. A lot of times we would import data sets from a CSV or an Excel file, for example, but this would be the syntax you could use to create a data frame from scratch. So running this block of code, we can see that now we have a data frame in our global environment, in addition to all of the values we have and the one function we created. Okay, next we can print. I'm going to print the student data, just this line here, because this is just a string up above, just to show you that we can look at this down here. It comes up in the console. But there's another way we could view our data frame, and if we go to the global environment and we click on the data frame, it will open up for us here in a nice little grid view so that we can see what it would look like in a tabular form. All right, moving on. Some more print examples where we don't have to do all of those, but when you get the file, you can run all of these codes. I just want to show the head function. We have a head function in Python that we use to view the first few lines of a data set. We have the same thing in our language, although it looks just a little bit different. The syntax is just a little bit different. And we can see in the bottom that now instead of getting all 5 lines of our data frame, we just have the first 3, so the head of 3 on this, and then we can view that here. We have a couple of different ways to index columns, and my preferred way is to use the $sign notation. It's very similar to how we use a dot in Python, but we use this $sign. So if I say print student data, which is the name of the data frame, $sign, and then name, which is one of the column headers, we should get all of the names. So I will run that with a Control Enter, and we can see in the console below we have all of our student names here from our student data set. Now you can also do it using indexing, and one important thing to note is that Python indexes from 0, but R indexes from 1. So just keep that in mind. It is a notable difference between the two. Other than that, there's a lot of similarities. So here are 2 more ways. You can see I get the exact same result. And again, I get the exact same result, the same output, 3 different ways to access your columns. Now, if you were to get an error when you're running your code, as we often do, and we want to be able to troubleshoot our errors, where are you going to find your errors? Well, the answer is they will show up in this console here. So we're going to make some errors just to show an example of that. So first, we're going to try to print this variable called undefined variable, and we don't have any variables in here called undefined variable, so we expect an error. Let's see what happens when we run it. And we get the object not found error, so this would tell us, oh, this is not in your environment, so you can't use it. Next, we're going to try to use a string for the square root function. And square root is a mathematical operation, so we would expect to have a number. And when we run this, we will see we get an error, non-numeric argument. So this is where you will find your errors so that you can, work through them or figure out what's causing your error when you run into one. It's very helpful to use AI tools to help you troubleshoot your errors. It will give you a good helper there to help you through. I often like to copy maybe some of the previous code as well. That way AI has a little bit more syntax or a little bit more context to help troubleshoot errors. And next, we'll show that base R will make a couple of plots. And when I say base R, I mean we don't have any libraries or packages that we call them in R installed. So in Python, we would often import pandas as PD or import matplotlib, or depending on what we're doing, other libraries. And R is also modular in that way, but we call them packages, and rather than importing them, we install them, and we will get to that in just a little bit. But this is base R, so this is what R can do without adding any of those things. First, a simple scatter plot, and we don't have a lot of data, so our plots won't be very involved. But you can see when I run it, it now comes up in the Plots tab of the lower right area. And I've resized it so we can see this plot. And R has a lot of intuitive color schemes that you can use. So we can try to now change this plot. And now we have orange dots. But I do like blue better, so let's go back to blue. Or we'll try green. Yeah, we'll do green, because green goes with red quite well. All right, so now we have some green, and let's add a trend line, which is called an AB line, or AB line. Now we have a trend line here for our points. We can also use base R to make a histogram. And we don't have a student score in this area, so it's a very basic data frame, so we have a very basic histogram. We can also make a box plot. Box plots are very fun, so that we see our mean and our outliers, so we have a little distribution. All right, next let's go on to working with some of these packages. ggplot2 is really popular for making charts and graphs. I would consider it to be similar to matplotlib for Python. So let's first I need to uncomment out the install packages, and if you haven't noticed, we use the # or # to comment out code. We don't have markdown cells, so any notes that you need to put in would just be commented the way that I have them commented, and they change the color as well. So we need to install packages, and I believe this one is already installed, so we might get a little message about restarting R, but let's try it. So since I already have it installed, it's going to ask if I want to do that. I'm going to cancel this, and then after I install a package, I generally comment it out so that I don't get that again in case I happen to run that block of code. But what we do want to do is run the library. So we have to do both to bring that in and make it accessible for us to use. All right, so more advanced plotting is going to happen when you use ggplot instead of base R. And here's an example. Also, these plus signs are adding together different aspects because it is modular in that way where you can sort of add different things to your charts and graphs. So this isn't really a lesson on how to use ggplot. It's more so a lesson on how to be familiar with the R interface. So we're just going to run this code and we'll learn more of those details later. And then I ran the code, I ran it, and then I'm going to look at my environment really quick because we have a plot in there now, but we do have to run the print code in order to be able to view it. So now I'm going to run that. And now we can see that we have this other plot down here, which we titled Student Performance Analysis in the labels argument here. Okay, moving on. We want to talk about our file management and our working directory. The reason that I prefer to use POSIT Cloud is because it's so much easier to manage your working directory. It should be automatically this area right here, although you can add folders and you could make a hierarchy. Just know that whatever you're working with does need to be in the same working directory, the same way that it has to be for Python or for SAS or other programming languages that we've used together. And so we can check our current working directory using the getWD function. So I'm calling it current dir for directory. And another thing in R really quick is this symbol here, the less than and dash, is the same thing as the equal sign. It's an assignment operator. So I could change this to an equal sign and get the exact same result. That's really a matter of personal preference, but that's what that means in case you were wondering, because I don't think I mentioned that in class. So we can also get a list of all the files that are in our working directory. So I'm making a variable called file list, and it is going to use the list files function, and then I can print file list. So let's run this block of code, and down here we are able to see that we have two files, intro_r.r and project.rproj. So it put everything in here that's in our files. And now we're going to make a file. So we made a data frame, and supposing we need to export this data frame because we might need to use it somewhere else, or load it somewhere else, or something like that. So we can use the write.csv. And then the second argument, I'm naming this function. When I run this, we can see, boop, we get a file right over here. So we made that. Just always be sure to include your .csv ending, because if you don't do that, then you will have a problem. It will make the file, but you won't be able to do anything with it. If I click on it, I can have a preview of the CSV file. So this is in a, wrapped up like a CSV. This is what it looks like tabular, but now I could export this if I wanted to by going to the more cog, in the settings here. I say cog because it, the little wheel, and then export, and then I can download it. But I'm going to cancel that, and I'm going to close these little tabs here. And next we're going to discuss getting help in R. So we have two ways, and so suppose that you're using the main function and you wanted to get some help on what that meant. If I use a question mark before this, I can run that, and it will toggle over to the help menu, and then we'll have all of this help information here on the arithmetic mean. And just to show you that the other one does the exact same thing, I went back to my files here, and I'm going to run help with mean in the parentheses as the argument. When I run that, again, it takes me over to the help tab, and once again, I get some help, some documentation on the arithmetic mean. All right, next up, R has a lot of useful built-in data sets that you can use for various projects, and we can look at what they are by running this data. So since this is base R, just have to run that, and you'll see all of these various data sets. And then if you're interested in one, next thing that we're going to do is we're going to load one. So we're going to get data using this data function, and for the argument we're going to use empty cars. And so now, after a moment, it's over here. I see it. Let me expand over here. And so I see empty cars here. Now let's print the head of empty cars so we can get an idea of what this looks like. So we have the head, so we can see that it looks like we have car models. We have miles per gallon, cylinders, and a bunch of other things in here. And then now it's up in our data set as well. So if I click on that, now I can view a tabular view of the entire data set. And this data is just available in R, just for you to play with. So finally, some workspace management. So this will list the objects that are in your global environment. So if I click on this, I can look down in my console. It gives me this list of everything that's in here. So this stuff matches what's over here. You're just able to view it over here. This might be helpful if you needed to, maybe you have a lot of code or you have a small screen and you can't see the environment very well, and you could see it down here. Additionally, you could use something like this if you needed to print out what was there because you were getting help from AI, because maybe the AI you're using doesn't take pictures or something like that, but this is helpful regardless for that way. Another thing that's really helpful is the structure. So we want to look at the structure of student data, and when I do that, I'm able to see that student data is a data frame. It has 5 observations of 4 variables, which it also tells me up here in the preview, by the way. And we're able to see that we have name, which is a character, we have age, which is numeric, we have grade, which is a character, and we have score, which is numeric. So we can see all of those things down here. If I had an error, I might take all of this code and copy it from my console if I wanted AI to help me with either generating a block of code or troubleshooting an error. We can also use the summary function, and this will give us some basic descriptive statistics of our data. So only age and score are numeric, so we get minimum, first quantile, median, mean, third quantile, and maximum. And for the strings, it just tells us, length, class, mode. So we can just see that it's a character. And now I will show you that we can remove things from the environment. So I'm going to add something to the environment, a variable called temp_var, which will just hold a string that says I will be deleted. So now we have that. It's in our values. I will be deleted. And with the RM, which is remove, it's going to be short for remove. We want to remove this. And just now as I hover over, there is a little helpful function guide. And so that would be the case for any function. So I just clicked on this summary function. So let's run this line here. I'm going to use the Control-Enter command, and we can see that temp_var has been removed. But I'm going to put it back really quick. So run that previous line. And I'm just going to show you an example that sometimes I like to remove things from my environment using the console instead of the R script, because I would just want to keep my R script cleaner. You can save changes in your R script, but your console is just kind of like a running, you know, history, I guess, of what you're doing. It's just, but you can run code here. So here, take a look, I will be deleted, and I have the same code here, and I'm going to run here, and now it's gone. So you can run code here, and you can also run code in your script. All right, so we can also remove everything from our environment. But be careful, because if you clear your entire workspace, then you won't be able to call any of these functions. So if I run that, I've removed everything. The environment is empty. And now if I try to run the structure of student data, I get the object not found error. So another way to clear your console, let's put something in there really quick. I'll just go back to the original variables. Oops, that's not the original variables. These are. And if I run this block of code, I can also clear my environment by using this broom, which is a little bit easier because it's, you know, you just click on it. So I just click on it. It gives me a little warning, a little alert, and now the environment is empty. I can also clear my console with a little broom. And now that's the end of this presentation. I hope that this helps you feel a little bit more comfortable working with RStudio, and have a great day.